So today I wanted to show you the process for actually calculating slope. If you haven't done yesterday's assignment yet, go back and do it first because I think it explains pretty well what slope is and why we need it or what we're going to do with it for that matter. But if you haven't, slope basically controls or is a numeric representation of what our line looks like. So what I mean by that is once you find your slope, if it's positive, that should kind of tell you that your line is running uphill. The reverse of that, if it's negative, it should be running downhill or look more like this. And then these two special cases, like let's say if you had a slope of 0, that's like a flat horizontal line, and a slope that was undefined or no slope, again, go back and watch the video from yesterday, it is a straight vertical line. Now, the majority of the lines that we're going to talk about and to come up with, they're going to be positive and negative. We'll on occasion have a horizontal line, and rarely, but they're not impossible, we'll have a vertical line. That's more so just because they're not that interesting. You can't really do much with a horizontal and vertical line. I think the diagonal lines, the positive and negative slope lines, are a little bit more interesting. So we'll probably spend more time talking about those. So again, we're not looking at graphs on these. What I want you guys to be able to do consistently well and consistently correctly is calculate slope. Come up with a numeric representation of how steep a line is. Well, in order to do that, we're going to, without a picture, come up with the rise and the run between our 2 points. Okay, so yesterday I just gave you a graph. You had to count out your rise and your run. Now I'm going to actually ask you to find it without a picture. So you're going to calculate the vertical distance between your points and the horizontal distance between your points in that order. So what you have to do is kind of think a little bit about when you graph a point, what controls where you're at horizontally and what controls where you're at vertically. As it turns out, your y coordinates control your vertical movement between points, whereas your x coordinates are going to control your horizontal movement between your points. So this might seem a little backwards when we get into doing the calculations, but if you kind of keep that in the back of your mind, your y's are going to be on top because they're vertical, your x's are going to be on bottom because they're horizontal. For some reason, I don't know if it's an alphabetical thing, but people always want to work with the x's first. So just be aware of that. So I'm going to give you this little line here, what slope is, how we use it. It's the same thing from yesterday, but we're going to focus on this last part here. The last part, y2 minus y1 over x2 minus x1, that is a formula. Those are not exponents. That is not y squared minus y to the first. It is y2, y1. Now, the reason there's a y2 and a y1 is because when you look at an ordered pair, you have an x and a y in each pair. So the ones and the twos are differentiating between the y's. The second y, the first y, the second x, the first x. So you've got to kind of keep these things in order. So I'll illustrate that, like literally I'll write that out as we're doing this. So every time I approach one of these, I look at the numbers first. So this is going to be my first x, this is going to be my first y, this is going to be my second x, this is going to be my second y. x1, y1, x2, y2. Those 4 numbers are going to go down here in this formula in that order. So when I start this out, I'm going to build this fraction. The first number I put in this thing is going to be my 4, y2. I'm going to subtract from that y1, which is 6. y2 minus y1 on top. My denominator is going to be x2, which is 10, minus another 4. Subtract these. This is just straight integer subtraction. Don't let the fraction worry you. The fraction is going to kind of take care of itself because our slopes have a numerator and a denominator. So what I need you to focus on is actually doing the arithmetic here. 4 minus 6 is negative 2. And then on bottom, I'm going to take 10 minus 4. That's 6. Now, I am asking you to reduce these things. If you're not sure on how to do that, talk to me. But if you're using a calculator, your calculator can reduce these fractions for you. All you really need to be able to recognize is that both of these numbers are divisible by 2 and divide them by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. You're done. Moving on, same thing. My first x, my first y, my second x, my second y. Again, these are not exponents. Those 1s and 2s do not affect these mathematically. So when I set these up to subtract, my top number, -1 minus -6, your formula says subtract. So I'm going to subtract a -6. And then 6, my x2 minus x1, which is 4. If you're not comfortable with integer arithmetic, use a calculator, but -1 minus -6 is positive 5. 6 minus 4 is 2. That's my slope on this one. I forgot my m over here. Your slope is always this variable m. I don't know why they picked m, but that's what it's always been as long as I've ever been taking an algebra class or teaching algebra. So the slope on the first one is -1/3. The slope on the second one is 5/2. Remember yesterday, no mixed numbers. Your slope is either a whole number if it'll reduce down to a whole number, or a fraction or improper fraction. I don't want to see anything like 2.5 as a slope. That doesn't work. Okay, there's a reason why we leave it as an improper fraction, which is what we're going to be doing tomorrow. All right, I'm going to go a little bit faster on these. I'm going to subtract these. y2 is 8 minus 10 for y1, and then 11 minus -11. That is -2/22 reduce -1/11. That's your slope. Okay, work these out. Make sure you can do this. If you can't find the slope between 2 points, the rest of this chapter is going to be very difficult. Okay, now I get you may not have the formula memorized. You don't have to. I will give it to you every single time. I expect you to use your resources. 6 minus -3 for my numerator, and -1 minus -3 for my denominator. That guy is 9/2, and 9/2. I'm done. I don't have to reduce that. It's not 4.5. Good luck.